Hello all, good morning. This is Dr. S. Subbalakshmi, Assistant Professor in the Department of Mathematics, SNS College of Technology. We are now on to the topic of Runge Kutta method. In the previous video, we have seen a problem on solving the first order ordinary differential equations using fourth order Runge Kutta method. In the previous video, we have seen to find the constants k1 and k2. Now we are moving on to the next step, which is finding k3. What is k3? K3 is equal to h into f of x naught plus h by 2 comma y naught plus k2 by 2. X naught plus h by 2 comma y naught plus k2 by 2, and substituting all the values here, which is 0.2 for h and 0 for x naught, 0.2 for h again, y naught, 2 for y naught, and k2 as 0.4402. This is what we have substituted, and simple minor calculations will give you the first value to be 0.1 and second value to be 2.2201. And what is f of x comma y? As discussed earlier, f of x comma y is x cube plus y. So x cube plus y, in place of x we are going to substitute 0.1 and in place of y we are going to substitute 2.2201. So on substituting it, we will have the value of k3 to be k3 is equal to 0.4442. So in a similar way, we are going to find the value of k4. What is k4? K4 is equal to h into f of x naught plus h comma y naught plus k3. What is h? 0.2. What is x naught? 0. What is h? 0.2 again. What is y naught? 2. And what is k3? 0.4442. So just we are substituting the values, known values here, and finding the value. On simple and minor calculations, we will be finding the value for k4. K4 is equal to 0.4904. K4 is equal to 0.4904 and del y. So after finding all the constants on Runge Kutta method, which is k1, k2, k3 and k4, we will be finding the increment. What is the increment here, which is mentioned as del y? What is del y? Del y is equal to 1 by 6 into k1 plus 2k2 plus 2k3 plus k4. This is what our formula says, and which is equal to 1 by 6 into k1 is 0.4, k2 is 0.4402, k3 is 0.4442 and k4 is 0.4904. And what is del y? Del y is 0.4442. Just on a mere calculation, we will be having the incremented value will be del y is equal to 0.4432. Now we will be moving on to the next step, which is y1. Y1 is y naught plus del y. This is what we have learned in the formula. Y1 is equal to y naught plus del y, which is equal to 2 plus 0.4432, which is equal to 2.4432 as a simple calculation goes. And what is y1? Y1 is equal to y of 0.2 as in the given question, and that is determined to be 0.4432. So we have found the value of y of 0.2 using fourth order Runge Kutta method in the first step. In the second step, as a second step, we are going to find the value of y of 0.4. Firstly, we have to note, for finding y of 0.4, we are going to fix the initial conditions as x1, y1, h and f of x comma y. These are the very important values to fix as a first step before moving on to the second set of value or second iteration in Runge Kutta method. So the initial condition changes because we have a incremented value in the previous step. So the first one will be x1 and the second one will be y1. H is equal to 0.2 and f of x comma y is equal to x cube plus y as discussed earlier. So with having this in hand, we will be finding the value of k1. What is k1? K1 is h into f of x1 comma y1 as an incremented value here, and h is equal to 0.2, and substituting all such values here, we will be finding the value of k1 here. In a similar way, we will be finding k2. What is k2? K2 is h into f of x1 plus h by 2 comma y1 plus k1 by 2, and substituting all the mere values from the given, and we are just simplifying it to get the value of k2 as 0.5431. And the next step, we will be finding what k3. What is k3? K3 is equal to h into f of x1 plus h by 2 comma y1 plus k2 by 2. We are implementing the previous constant in the next constant formula. So just substituting all the known values here, we will be finding the K3 value, K3 as 0.5484. And on simplifying it, we will be having the value here, mere simplification. And the next step is finding K4. K4 is h into f of x1 plus h comma y1 plus K3. And this is what the thing is. K4 is 0.6111. 6111. Del y is the next thing to be to find is del y. Del y is equal to 1 by 6 into k1 plus 2 k2 plus 2 k3 plus k4. This is what the formula says. And after this, we are just simplifying it using mere simple calculations. We will be having del y as 0.5474. And now the ultimate aim is to find the value of y2. Y2 is equal to y1 plus del y, which is equal to y1 as 0.4432 from the previous iteration, and in the second iteration we have del y as 0.5474, and on adding these two things we have the y2. What is y2? y2 is 2.9906. So the incremental value have been found here, and it is added up with the previous set of value of y1 here and found y2. So we have found y of 0.2 here, and later we have found y of 0.4 here. So this is 0.4, not 2. And this is how we implement the formula of Runge Kutta method to solve the first order ordinary differential equations. So this is what the Runge Kutta method is. Thank you all for listening to this video. Thank you.